Our next and unfortunately already our last lecture comes from the managing director of the company Aitsubi. It's Wilhelm Klatt. He works in the computer vision department at Bielefeld University of Applied Science, and his works focus on testing and developing computer vision solutions for use cases and circular value creation. In his lecture, Wilhelm Klatt will present a lean automation approach for use cases in the field of waste management and logistics. So, Wilhelm, the stage is yours. Share your screen, just open your mic and then go ahead.
Okay, hi, I'm here.
Yeah, I can see and hear you.
Share screen, and then I will share my screen.
Perfect, I can see your screen.
Okay, and then I will just, now I can see my slides?
Yes, we
Perfect.
can see your slides.
Thank you for the invitation. I'm happy to be here. My name is Wilhelm Klatt. I'm the CEO of company Aitsubi Land and Machine. We are focusing on computer vision, and we love use cases when it's about recycling and circular economy. And as you already mentioned, I have also a research position at the FH Bielefeld, where we do a bit more research-oriented stuff. And a bit about us, we are a family-owned company. We only do artificial intelligence, so we only work with neural networks. Our goal is to create affordable AI for mid-sized enterprise especially, and everything that is around recycling. These are use cases we love. If you want, you are invited to our work group. We have something that's called KI Mittelstand. It's a quarterly group of researchers and company representatives where we discuss use cases, applied use cases. What we do is we test whether computer vision or a machine can learn a specific task. What we also do is we build machines, industrial machines based on computer vision. Two of those you see here. It's our Ferdinand and Gertrude, two machines that we have used with customers. And what we also love to do is build open source tools. These are not products that we sell, but general tools that help machine learning engineers, but also companies to apply AI more easily and affordable. If we talk about smart cities, then there are different ideas, concepts of smart city. Our approach towards a smart city is everything that is related with, now this is here in German, Entsorgung and Versorgung, everything that is with supply of something that the society needs, and also something that is how to get rid of things that the society does not need anymore. And this is our viewpoint on smart cities, and these are the fields where we like to work. I would like to give you two examples. Usually we do industrial use cases, but I would like to give you two examples where we are very, very close to a smart city or to non-industrial applications. So you have those cobblestones in all the cities, right? Some of these places where cobblestones are, they are, for example, historic, and some of these stones are very old, and they are also very valuable because it is natural stone, it is of high value, but the problem is they are not easily accessible for people with limitations. So, and then there is, I think, a requirement of the European Union that all areas in a city needs to be free of barriers. And so what cities are now forced is they now have to change those places and those cobblestones. And the only feasible way that they actually have is to get rid of the old stones and buy new ones, usually then buy them from China with like poorer quality, so not natural stone, but some kind of other stone. And they also don't look as nice as natural stone, and they also they lose the history that they have of this specific stones that, for example, important people walked over them from the past. And so what we do with our partner Cobble AG is that we reuse those stones. So those stones are excavated, they are cut so that they have a flat surface, and then they are placed back into the same place where they have been. So it is a perfect example of circular economy. You don't throw it away, you just reuse them, but in order to be able to reuse them, you have to do something with this material. You have to change it, you have to improve it. In Germany, this would not be economically feasible if it weren't be almost fully automated. So automating this process, cutting of the stones, also inspecting, are these stones broken or damaged in some way, and then also laying the stones back in place. And our part is, so we do everything that is visual. This is our part here. So we inspect all the stones before they are cut, after they are cut. Are they somewhere damaged? This is an example of one of the stones which is already cut. And so you need to inspect whether the cutting process damaged the stone in some way. And also you see in one corner is somehow like it's not a perfect rectangle, right? And our task is then here, can we arrange the stones in a way so that we don't have huge gaps? So we don't need to throw stones away, which are perfectly good, but they have an odd shape. And if you just lay them without order, then you would create huge gaps, and then this is also not feasible. So this is just one example where you see like computer vision can be used for use cases or for things that you may not have imagined where computer vision can be applied. So this is just one case. The other case or the other field that we work in quite strongly is waste management. And a lot of our work is with the FH Bielefeld. And I will just give you small examples. One project that we have is where we just use the smartphone. We try to improve the interaction between citizens and the city management authorities. So, for example, if citizens can, if they don't know how to separate waste at my location, then there is an app. You can just take a picture of what you see, and then it is classified by an algorithm, and then it accesses the database and tells you at the location where you are right now, you need to sort it in this way, because every city has different ways of sorting, and this is one approach where we can just use computer vision to assist behavior that is then easier for the city to manage the waste. Also, for example, you can report things. We've heard where you can you collect data on where are roads damaged. This is one approach. Another approach would be just to use the smartphones of every citizen, and instead of the citizens making pictures and fill out I forgot the name, formula. So they don't need to provide all the information that you would need. It's a lot of work to report something, and we use computer vision and, for example, the information, where is the smartphone located, and also what is this about? Is there something damaged, or is there waste somewhere lying around? So we use computer vision for this. And of course, the detection of waste, identification of waste, and also it's in Germany it's called Störstoff. So if the waste is not pure, if there are some materials in ways that do not belong there. So unclean waste can create a lot of problems in the whole process of waste management, and so we try to solve this by building computer vision solutions that can be used with bins on vehicles, or also where trash is burned, for example. This is also a field where we work. One thing I would like to give you as an impulse is we are working on, it's an open source project, and we are working on a tool. It is a digital tool which has the idea that companies or cities or organizations can use machine learning, or can apply machine learning without the need that they have to train algorithms, which is something that requires a lot of resources and know-how. And we are working on a solution which is a bit different than what I've seen so far in the computer vision space. It is a label, a new type of label that we create. You are familiar with QR codes, right? Especially the pandemic has, I think, promoted the use of QR codes, for example, to identify yourself when you go to some place, or in the Corona app. And so you are familiar with QR codes. But the problem is with QR codes, if you want to use them, for example, to detect with the camera or with the scanner that something is present or something is at a specific location, then there are some disadvantages of the QR code. One is nobody of us can read the content of this QR code. It's a binary code. It's something for machines. It's not for humans. And barcodes and QR codes are those machine codes, and humans cannot read it. Humans cannot create them without hardware, without technical assistance. And if in order to read the content of a QR code, you need to properly see the QR code or barcode. And usually there is some manual work included, for example, a human being having some sort of hardware, a scanner, and then it needs to be scanned by hand. And we thought, okay, can we now have deep learning, machine learning since a few years, and it was proven to work reliably if used correctly. Can we just have a label that both humans and machines can read, and can we simplify those automation processes? And so what we are developing right now, this is with the FH Bielefeld, this is also a research project, a simple system. It works similar to a QR code, but it has alphanumeric symbols which a human being can perfectly read, and also draw or print or spray onto a surface. So you can, for example, label a specific location. You can label boxes, containers, whatever you need to identify when a camera looks at it. And it is a hybrid, so we merge two worlds. One is the computer world, the binary, and the other world is one we know. So for example, we call cars VW Multivan. These are all labels that we can read. But the problem is, if we would now use AI to read everything that is readable, the AI would read anything. So for example, even if there is something written on a person's t-shirt, it would also read out this information, and it would contaminate, it would bring the data information into a system, into a process that you don't want to have. So we came up with this structure where an AI, a deep learning algorithm, is able to detect all the human machine codes. This is how we call them in a picture, read them out read them from those images in a reliable way. And so you don't need to train an algorithm to understand what is a box, or how do boxes or pallets or other things like how do they look. But you can have a shortcut. You only use markers, and it's very easy to apply those markers onto these objects. And we take care for the algorithm, so you don't need to train anything. This is a very universal tool, just like the QR code. A very simple use case. This can be anywhere for where you have logistics, anything in the city where materials flow, or things move, or people also move, or objects, cars, trucks. And so here you have the code. You use two codes. One is for the location. You just print it on the floor or on the wall, so that the camera detects the location. And also you have a HM code on a specific box. And then you place a very simple camera. This is one of our cameras, Lisa. We created it on our own, just because there is no such camera available right now from any vendor. It's a prototype. So you would just place a very simple camera, and the camera would take regular pictures, for example, once a minute, and then it would send those images to our AI. We call it Albert. Both Albert and the HM code are open source available. And so what the AI does is read out, do I see codes in this picture? If yes, what is the content of these codes? And Albert can read HM codes, but also can read QR codes and barcodes as well. And then this data is then provided to your system, and then you can decide whatever to do with it. So in this case, you would say everything that starts with a P5, for example, is a location. And then you have specific number, a set of numbers for your objects that are moving around. And you can also, for example, if a specific HM code is visible, then you can, for example, send out a notification to an employee or to someone who requires this information in real time, right? So our so this approach does not understand are there people on this image or who is on this image. The only thing that this neural network does is to check for these codes and to read out the content of these codes. And then it's very simple for you to automate with this approach, because you can decide with a position of the camera, what is the field of view of the camera, and then you can say, I want to know if this object is at this location at a specific point in time, and then you just point the camera to this location, and then you use two of these HM codes to automate it. Why is the code so interesting? The code is based on AI, so you need an AI to read out, to detect those codes and to read them out, but you don't need to develop it. You can use an existing AI, and all you have to do is just use those HM codes and a simple camera, just as you would use with QR codes. Everything is open source. This is a tool that is not restricted in any way. You can use it commercially, and we see a lot of application fields there. They are easier to use than barcodes and QR codes because you can just paint them by hand, and everyone can read them, and everyone can see if some information or some label is wrong. With QR codes or barcodes, you cannot see what the content of the code is, and you cannot easily detect mistakes there. And the hardware requirements are extremely minimal. You just need a camera. Sometimes you can also use existing cameras, for example, security cameras. There is no special requirement for the camera to use this approach. What is interesting here, and this is also a little bit a hint or something for ideas. This method of automation is very is made for using AI very close to the camera, or ideally inside the camera, so that you have a camera that is able to extract those codes and then only send the content of the codes to a server, so that they are then used, so that all the images, all the raw data stays in the camera and is not actually sent anywhere. That's a very interesting approach. It's technically feasible, and we have a prototype of this kind of camera, but it's a very raw prototype. And I think this gets interesting once you have an industrial solution, something that you can buy. It works out of the box, and it has all the it fulfills all the requirements for IP67 and other certifications that you need to work with it. My impulses, my takeaways that I would like to give you: computer vision can be used in so many ways, and somebody who is not into machine learning is not always able to evaluate where it can be used. And so my recommendation is talk especially with leading startups, because they are very, very close to on the application side, and which is sometimes not always good if you have research partners. They are also good, but I think just to identify those low-hanging fruits, I think speaking with established startups is a good way here. What I also see is many computer vision projects seem quite complicated, and as there are shortcuts to automate a process, and using a code like an HM code that I've showed you is one way of using shortcuts to avoid to train a neural network for every specific company or every specific type of objects. This is something you want to avoid because it's usually very expensive. And there are low-hanging fruits everywhere. I would try to invest enough time to identify those. And if it's your first project in the field of computer vision or AI, I would try to go for a very simple one that is able to create results within a year, just to get the experience for more challenging projects. And maybe it works, maybe not, but I hope that instead of an email, maybe I will get a call actually from someone who wants to talk about some of the things that I've showed you. It's always a bit difficult in pure digital formats to connect, and maybe just calling is one simple approach to get through the time where we can only meet in a digital way. But I hope in the future we can make it on premise as well. I mean, on site.
So thank you, Willem, for your interesting talk.